Good morning, learners. In this video, we are going to look at question 4 of the November 2016 question paper, which is a functions question with an exponential graph. It says there, sketched below is the graph of hx given by a to the power of x, where a is bigger than 0. R is the y-intercept of h there as shown on the sketch, and the points 29, P29, and Q, which is B1 over 81, lie on the graph of h. And then 4.1, write down the equation of the asymptote of h. Right, now I know for an exponential equation, this is exponential. Typically, the exponential equation looks like this: ab to the power of x minus p plus q, where my horizontal asymptote is simply y is equal to whatever that q value is. If this equation given here is just a to the power of x, there's no plus anything, so the q is obviously 0. Meaning that this equation of the asymptote is simply y is equal to 0, since the q in this given equation doesn't matter what the a is, the q there is 0. So y's q is my horizontal asymptote. Then 4.2 says determine the coordinates of r, which is the y-intercept. Now, even if I don't have a, that does not really matter. The equation is y is equal to a to the power of x, and to get a y-intercept, I make the x 0. That will make this, doesn't matter what the a is, will make it 1. So the point R will be 0, 1. Doesn't even matter what the a is there. But 4.3 now says actually calculate the value of a. Right, so in this equation that I have, y is a to the power of x. I have the point P, which is 29, that lies on the graph, and the point Q, but I'm missing a value there. So I'm going to use the point P29 and substitute that into the equation. So the x is 2 and the y is 9, so then a squared is 9, meaning that, well, if I think of factorizing, bringing the 9 over and then doing difference of squares here, the a can actually be 3 or negative 3, but they said in the question that the a is positive. The a is positive, so obviously it's going to be a is 3 there. 4.4 says now that D is a point such that DQ is parallel to the y-axis. DQ is parallel to the y-axis, so this obviously then Q also lies on this line there, the point Q. DQ parallel to the y just means it's a perfectly vertical line, and DP is parallel to the x-axis. Alright, so this is a perfectly horizontal line. And then they say calculate the length of DP. Now, for perfectly horizontal lines, to calculate that distance, you can just take the x value there, which is 2, and subtract then the x value there at D, which is that value B, obviously. Since this is a vertical line, the y value is going to stay, are going to be different things, but the x value is going to stay that b value all across the line. The y value is going to stay 9 there all across that line there. So I need to take x2 minus x1 to calculate the length of dp. I'm going to take x2, which is 2, minus x1, which is obviously then b there, but I do need to calculate that b. Alright, so b is part of a coordinate b1 over 81 that lies on the graph, so I can just substitute that into my equation. The q is the point b1 over 81, and substitute that into the equation. That is my y value. So the y value is 1 over 81 is equal to a to the power of x, which is b, and the a I calculated as 3. Oh, sorry for the mistakes there. 1 over 81 is 3 to the power of b. Okay, all right? And 81, 81 is 3 to the power of 4. Let me just double check that. 3 to the power of 4, and since it's under the line, to bring it up, I can write that as 3 to the power of negative 4 is 3 to the power of b, meaning then obviously that b is negative 4. So to calculate dp, I can substitute in there. dp is 2 minus the b, which is negative 4, which is then 6. Okay, just to explain the logic between the logic behind this to calculate the length of dp. If this x value here is negative 4, that's also going to be negative 4. Then the length from there to there is 4 units, right? From negative 4 to 0 is 4 units, and then from 0 to the 2 is 2 units. So the 4 units and the 2 units giving me 6, but the calculation will go to and subtract that negative 4, which is then going to add it to that 2. It's easier to understand it on the positive x-axis. If I have a 2 there and a 5 there, the distance between the 2 and the 5 is 3 units. I obtain that by taking 5 minus 2 is going to give me the 3 units. It just extends to the negatives as well. Okay, and then the last question here, question 4.5, bit of a problem solver, says determine the values of k for which the equation hx plus 2 plus k is equal to 0 will have a root that is less than negative 6. Okay. All right, so let's break this down a little bit. The hx plus 2, that p value there in the equation, I know moves the graph left and right. If that's a plus 2 there, in the place of the x, I replace with the x plus 2. The equation is going to look like this. So the equation of h is 3 to the power of x, right? Because I calculated the a as 3. So the equation of h, x plus 2 is going to, then I replace the x with the x plus 2 is going to be 3x plus 2, right? Which technically is then a p value which moves the graph left and right. With the negative there, it works the wrong way around. So the plus 2 is actually going to move the graph 2 units to the left, meaning that this is this graph here that's been moved 2 units to the left, which will place this point here on the point 0, 9. If I just move the x 2 units, the 9 is going to stay where it is, and this, which is at negative 4, 1 over 81 is going to move to negative 6, 1 over 81. And since they ask here something about negative 6, I suppose this is the point that they want me to look at, because moving the 2 units to the left is placing this q value. The new q value is now at negative 6, 1 over 81, right? So they want the root to be less than negative 6. Okay, this is now standing there. I'm seeing this as negative 6 now. Okay, so if I have the point negative 6, 1 over 81 here, to make this a root, I'm going to have to move the graph down, right, with 1 over 81 units. Down 1 over 81 units is going to make down 1 over 81 is minus 1 over 81 is going to make this, if I make that k, negative 1 over 81, that's going to make the root exactly negative 6. So they want the root to be less than negative 6. Now, how can I accomplish that? If I move it down, then the root is negative 6. If I move it up a little bit, let me move the x-axis because it's a bit difficult to move the curve. Oh, I can actually move the curve. Let's move the curve. Okay, so if I move this curve down so that that point lies on the x-axis, right, then that's at negative 6. If I move it up a little bit, do you see then that my x-intercept is going to be maybe at negative 7. If I move it up a little bit more, negative 8. If I move it up back to the point where it is currently now. It's not going to cut the x-axis. So I cannot move it up, right? Because then it's just not going to cut the x-axis. Where it currently is, it's not cutting the x-axis. So I do need to move it down, meaning I do need to have this x value at least something smaller than 0 so that it moves down. Negative is going to move it down, but then I cannot move it down any more than 1 over 81 units. That is the 1 over 81. If I move it down more than 1 over 81, the root, the x-intercept, a root is a solution, right? The x-intercept, the root is going to be something. So if I move it down 1 over 81, it cuts at -6. And then if I move it down, say, more than that, so 1 unit, then it's going to cut the x-axis at something like -3, which is bigger than -6, right? So I don't want to do that. I don't want to move it down any more than 1 over 81. So at least 1 over 81 moving it down, and then no more than, I can't move it up, so I must move it down specifically. And then my parameters is x, the k, not the x, sorry. The k must lie between -181 and 0. Okay, so that is question 4. I'll see you in the next video for question 5.